Hello, my viewers. My name is Young with Sunday, and I welcome you all to my channel on PU for More Academy. Looking at this topic, it also very important lesson that we need to understand. The reason for this is that there are a lot of people who are in the forming industry, and they are formers by profession, but certain things they do not understand. And the purpose of this lesson is to let them understand this, because just like I said, reactions is about, for you to able to interpret chemical reaction, you have to pay serious attention, and you must understand reaction mechanism. Okay, right from the reaction of polymerization reaction stage to the last stage of the reaction, how these things are called step by steps in forming. Now, I've been seeing a lot of people complaining about imbalanced reactions mechanism. Some say, oh, calibrate, the polyol is not delivering well, water is not delivering well, these are not delivering well. At times, that is not the root cause analysis of that imbalanced reaction. The only problem that seriously occurs when people do not pay attention is the behavior of gas molecule at different sea level, at the sea level, above the sea level, and below the sea level. And that is why I use formulation of 22. That's water blown or formulation for us to understand this. Now, in the last presentation, we also look at a PU formulation of 22 at the sea level. At the sea level. That is why one may argue that I'm in China. I'm using a part per 100 of water 4.4 to produce a foam density of 22, and that density give me 22. The person is right. Now I can also say in Nigeria, I say, wow, I'm using part per 100 of water, okay, to that of polyol 4.8. I'm also achieving foam density of 22. When I say this, I understand that the air pressure at these locations are not the same. But if, let's assuming we are running it at the sea level, we will all use water of 4.55 to achieve a foam density of 22. You know, in forming, there are things as a former, a process chemist, and engineer, you are in charge. Okay, there are some, it is not your will, it's under the grace of Almighty God. For example, you produce from the atmospheric weather change. The weather, you are not in control of the weather, but you can control the raw material temperature excellently, get a good balance formulation, but that one will affect your reaction. Now, we look at this 22 density at above the sea level. Above the sea level. Above the sea level, what will happen? Okay, you will see have part per 100 of polyol. Remember, at the sea level here, we say water equal 4.55, and that is good and excellent. But remember, this was at a sea level, meaning you are at the basin line, okay, whereby not above, not below, things are stable. So a location at the sea level, taking this into consideration, you are going to have a best and efficient forming process with less troubleshooting. But if you use this idea to still have a forming process at the sea or below level without understanding the attitude of that location, the premises at which you are forming, you are going to have much troubleshooting at the end. Is going to generate much waste. No two ways about that. On some block will fool the whole factory. Okay, now what are we trying to say here? What we are trying to say that above the sea level, the gas pressure become lighter. lighter gas pressure above the sea level. So in that case, the force that is acting on forming, more gases is going to be produced above the sea level. So in this case, you are going to have more gases produced above the sea level. In that case, the foam will undergo what they call over expansion. And over expansion in forming lead to a soft foam, because the gas molecule will blow a foam above the desired density that you intend to produce, because of the much gases in the environment that now interfere with the gas in the forming process. Okay, so in that case, the foam will not be running under air pressure. It's just like something is pressing the foam, so the foam will be struggle to rise above the sea level. So this one, the foam will have enough chance, okay, to expand, okay, even over expand. This thing can easily collapse foam if you are running extremely low density. Have that at the back of your mind. Okay, so the problem is not about poor catalyst, imbalance of the rest of the catalyst. This is the secret problem that is disturbing your forming process. So in this case, what you need to do, you can decide to bring water down to 4.2 or 4.3 part. Okay, therefore to keep the density at still 22 degree centigrade. You know how gas behave. At a higher pressure, gas will compress. At a lower pressure, gas will expand. Take example for a car, motor, tires pumping by vulcanizer at the roadside. That is typically what happen in forming process. So paying attention to air pressure is very, very important. Gas expand or gas produced by the reaction of CO2. We got that stage, a gaseous or stage, whereby the CO2 is produced. Now, the amount at which these gases influence the blowing of the foam depend on the air pressure above the sea level, at the sea level, and below the sea level. So if you are setting this formulation, the same formulation in my previous lesson that I posted before, okay, you still use it, but you need to work on your blowing agent, which is the chief blowing agent, water. So I'm using water blown formulation. For example, even though you incorporate MC, you know that the amount of water will change. Okay, let's assuming at the sea level you use 4.55. If you are bringing MC, this water will not go. You need to come down, substitute to balance MC, having in mind that 7 kg of MC equal to 1 kg of water of the same blowing effects. You understand? So you need to balance this to see keep the density at 22. So this is all the secret of a forming technique of foam density above the sea level. Always have it. I did say that the standard pressure of the environment is what? 1 bar. 1 bar. So in this case, you need to have what they call digital barometer. A digital barometer will measure the value for you, thereby enable you to know how you set your formulation. I hope this is very, very interesting. Continue to like my page, share, and I hope this is going to give you a much insight about forming. My viewers, thank you so much. Continue to subscribe and watch and share. Thank you very much. God bless you, my viewer. Bye bye.